Okay. So what you want to get the data set from in the public repository. We just want to press our Kaggle data sets, then click on enter to search it. Okay. So let's say we want to do something like do we want diabetes or breast cancer? Which one? Which one should we go for? Anyone? Is it diabetes? Is it breast cancer? Which one? We can go for any project anyway. I just want our input. What do we want? Of your outside there. Okay, are you on the call? Okay, about what can you say? Do you want diabetes or breast cancer?
On diabetes.
Okay, let's go with diabetes then. So let's try to look for data sets. So let's look for data sets. And this recent 8 months ago. So let's look at this. So we have our age, we have sex, we have the ethnicity, we have okay, we have ethnicity, we have BMI, we have the glucose, we have age HbA1c. So let me look at it. We have blood pressure here. So we can get what we are trying to look for is that we want to look at the end of the prediction data set if there will be an outcome. What is an outcome? An outcome is something that will show maybe this particular person has diabetes or not. So in this case, we can't find something like that at the well, who told? They said 10 of 21. So let me click on 10 of 21 columns. I want to see everything. So I want to click on select all, then click on apply. So let's see if I will get what I want. So we want something like this. I want to look at the last thing. So it's still, what is this one? I'm not sure. You have 0 and 1. What is this? This is gestation, diabetes. Okay, I don't think I will use this data set. So let's look online. So you have 17 columns here. So let me just click on everything. You can just select all the columns here, then click on apply. So you can see all the columns now. On this framework before you download them. So we have age, polydipsia, we have weight loss, we have fitness, polyphagia, we have all these. Okay, we can't see the last thing. It's not there. So, okay, this is 9 of 9. Okay, we have pregnancy, we have glucose, we have blood pressure, we have the insulin, BMI, then we have outcome. I think outcome should be people that don't have, and one should be people that have diabetes. Okay, let's just download this. You can just download it here. So let's give it a minute. We're not downloading. Okay, it's downloaded already. So you want to go to um so we want to click our normal thing. So the first thing is we want to change this trend, diabetes prediction, right? So the first thing you want to do is you want to import the libraries. You can tell me what are the necessary libraries we need to import here. Anyone, please can you unmute your mic? Anyone?
Pandas,
Okay, pandas.
PD.
Okay.
Import matplotlib dot pyplot. As PLT.
Okay, what else?
Import numpy as MP. Then import scikit-learn. Is it from scikit-learn?
Okay. So let me just import seed1.
Okay.
So we have from sklearn. So why are you importing sklearn dot what?
The model. Which one first?
Model selection. Okay.
Then import
Import what?
train test, I guess.
Okay. From sklearn dot the processing. We've done everything here yesterday. So
Yeah.
that's why I'm rushing. Import. Import leader. Okay, from sklearn dot um okay, let me do lessons. Moments. Okay, I think this accuracy score should be small like that. Okay, so we can see we imported all our dependencies, and I've explained the use cases of all these things that we have here. Even we are not done, but yeah, this is a good starting point. So the next thing is we want to import or we want to import our file to Google Colab. So the next thing is just add more line of code. So we want to do something like ex equals to what pd dot read CSV. Right? We are trying to read the CSV because I know it was a CSV file. So now let's try to import it. Mm, okay, I think it's important. So copy path. Okay, should we? Okay, so let's move on. Let's write something. Okay, just give me a minute.
I have a question. Yeah, is it
I can hear you.
okay? Oh, we don't have to like unzip all the data sets, right?
No, because I downloaded this directly, which is why we don't need to unzip it. Did you get what I'm saying?
No.
That's what I'm coming. Okay. So when we were downloading the data set here, so we have two ways of downloading data sets. So I can download it directly here, then I can download it here. If I should download it here, can you see? You can see something like download as zip. So if I want to download that as zip, I can just click on this one. But let's say I don't want to download it as a zip. I can just click on this one to just give us the real save file without the zip file. Do you get that?
Yes.
Okay, so because I chose this one was the reason I did not unzip it. Do you get that? Okay. Okay, these are our data sets. So let's try to understand it. We are trying to do diabetes. We all know that there are some diabetes that can be caused by pregnancy. Also, we have the glucose level here, we have the blood pressure, we have the skin thickness, we have insulin, if the person and the insulin level of of the said person. Then you have the BMI, you have pedigree function, that is pedigree, that is how it runs in the family. Then you have the age of the person. The outcome here, we have one, you have zero, we have one. One means the person um has diabetes, while zero means the person is not suffering from diabetes. So we can see the first thing you want to notice is that there are no English words here, right? So machine Excel can, sorry, how do I keep saying Excel? Our machine, our model can understand all the things that are here. You get our model can understand all the things that are here. So the next thing is you just want to do some data analysis. You want to do that info. Let's get some information about this thing. So I'll be very fast because so we can see all of them are integer. There's no object data type there. So it is very good and okay, we are good to go. So let's look at the shape. How many columns do we have here? How many rows? How many stuff do we have here? We want to do something like pf dot shape. Sorry, this is not supposed to be data, but here. So we have 768 and 9 columns, which is very small actually, right? So and there's something we call overfitting. Overfitting means that the data you are supplying your model is too small. So your data can understand virtually everything. So this is an example of maybe I think yeah, this on is it underfitting or under overfitting? I think this is overfitting. So it might return error, but at least I will try to show us how to navigate our way to it. So we have gf.shape. So the next thing is we want to look at there are not much to do. We are not doing data analysis here. We are trying to just do Python prediction level. So the next thing you want to check, let me check. Let's see if there are null value there. So to check null value, you just want to do something like is null, right? I think I've explained this one while we were doing uh while we were doing what do you call it? Data analysis in Python. So you can see we have 000. There are no null value there. So since there are no null value there, we want to split this into Excel into X and Y. So who can tell me what is the X here? What is the Y here? Anyone else? I want to know. Look, these are all the columns that we have. Who can tell me what are the X columns and what's the Y column in this particular case? Anyone, please unmute. Thank you.
The X column, I think the X is the columns without the outcome, then the Y is the outcome itself.
Okay, thank you so much. So you can just separate this one. X equals to X. Let's say D here. Can you see it's already giving us what we call it, and then an X code. So you can see df dot drop, that is inside this data frame. I want to drop a column, which is outcome, and axis equals to 1 means it should be a column, not the row. Then we have y should only assume the outcome column in the part in that data set. So if I should run this now, so I can see everything is running. So let me like add more lines of code. So let's say number two, I want to do something like x. If I should call x, yeah, let me call something like this. So if I should do, sorry, okay, can you see this one is giving us, remember we had nine columns before. So this one is giving us 768 and 8 columns for x, and y shape is giving us 768, and definitely the one is not written, but yeah, there is one here, which is why we have something like this. So we have 1 and 8. That means these are our 9 columns. Okay, great. So the next thing is we separated them into x and y. We're actually supposed to standardize. The major reason for standardization is that this one, can you see the, let me call something like this, df.std. STD means standard deviation. So once you look at the standard deviation between them, so you can see pregnancy has 3.3. You have uniform standard deviation when you have numbers ranging from 0 to 1. So you have this one 3, this one 31, this one 19, this one 15, this one 5. They are inconsistent. So you want to standardize the x value. So to standardize x value, remember I've loaded something we call standard scalar is used for standardization. So you just want to activate your standardization. So how do we activate our standardization, Mr. Abbas? I know you were here yesterday. Anyway, to activate standardization, you just write any something like this. You can just write SC equals to standard scalar. So can you see something like this? So the first thing I'm calling here is more like, okay, I want to activate my standard scalar, which is which is responsible for scaling my x data set, or x values, all the values in the x columns. It is and it will be scaled. That is, the values will range from 0 to 1 or 0 to 2 now. So next thing I'm asking is that, okay, inside my x, fit and transform whatever is scaled inside my x. So if I should call it now, so if I should, let's say I want to print x. So let's do something like this. Can you see all the numbers that are there now are now ranging from 0 to, let's say, 1.94. I can see 1.94 here, but I can't see something more than that. You can see all the values are now ranging from 0 to 2, which is very good now. If we do something like x.xdb, I think, I don't know if it will be, it will, if it will return an answer. Well, let's try it. So can you see, it is now giving us 1, which is very good. I told you the other day that, other than that, if you have a consistent standardization, that's when you have 0 to 1, and you can see it's already giving us 1, which means our values are in good shape now. Now let's add more lines of code here. So since we have splitted our columns, we standardize, which is the second thing. So the next thing is we want to call our train test bit. So we want to dedicate some data to train our data set, while we want to dedicate some to text our data set. So in case you were not here yesterday, I explained that I explained that training data sets is what are the data that we use to train our model, to understand, to find a pattern through it. You understand? Then testing data sets will be the will be the a little exam we will be subjecting our model to know the accuracy, how much it can predict our values. So in this case, that's basically what we want to do now. So you just write something like extreme. So because you want to split them into extreme, so you write something like this, extreme. I'm trying to split my x into extreme and what's x test. I'm trying to x test. I'm trying to split my y into y train and y test. y2, y, right? So you have to call your train test suite. Remember, we've also imported our train test suite. When we call something like sklearn model selection, you can see something like 10 train text splits the other time. So yeah, that's one. So you can just write something like train test splits. So you want to write your x and y, which you are trying to split, the x and y. So next thing you want to write is you want to write test size. That means okay, in 100%, what how many percent do you want to test your data? You want to use for testing your data set? You might use 20%, you might use 10%, thereabout. So you just want to write your test size. So you can just write 0.15. I'm just trying to use 15% there. Okay, I think you can only write 1%. Let's just use 0.1 to test it. Then you can just write random states. You can write anything there. So let's just write random states too. Okay. So since we are done, we've splitted our stuff now. So to be sure that we splitted it, you can just store something like this. Let's do extreme. We splitted it. It was the old data set was like 790 something. So now let's just do something like this. This is what I was trying to. Yeah. So we want to know, can you see, for training our data set, out of 794, we'll be using 691 to train it. Then we'll be using 77 to test it. Can you see? Then for our Y, can you see, just 691 and 77. Basically, this thing. So the next thing is we want to call our model. What's our model here? What model have we imported here? In this particular case, the only model in all this library is logistic regression. I told you yesterday that we have more than just logistic regression. We have support vector machine, which in short we call SVM as the acronym for it. SVM, we have logistic regression, we have KNN, we have RGB, we have a whole lot. We have linear regression also. So let's just try to use our logistic regression. So the first thing is we want to activate it. So who can tell me now, how can we activate our logistic regression? Anyone? Please unmute your mic. Okay, because I don't want to cause more distraction. So to activate my logistic regression, you just write something equals to logistic regression. Just these brackets is what activate our model. Anything when you hear something like I want to activate something, how do I activate it? To just add parentheses like that. So let's just activate our model. So our model is already running. So now this model, that means whenever I call model, that means I'm referring to activated machine learning model, right? So you want to write my model, which is my machine learning model, dot fit. What am I fitting on it? I'm trying to fit my X train because yes, this is what I want to use. These are the data set I want to use to train my data set. X train and what Y train. This is the outcome I want to use to teach my data sets. So can you see it's already giving me that okay, this blue line is logistic regression is running. So the next thing that I want to know is that okay, what's the score? What's the accuracy score on the training data set? So you want to do something like model dot score. So let's just do X and Y train. The same thing from now, Y train. Okay, it's giving us 77 for Android. Okay, it's giving us 77 for training the accuracy score. Now let's test what's the accuracy on our test data set. So instead of X train, this one will be what? X test. This one will be Y test.
Oh, sorry, I want to ask. We don't need to fit in our test, Abby. Like
I don't get.
we don't need to do model dot fit for the test.
No. We are using this one to train data and model. That's why
Okay.
we are fixing it. But this
Okay.
one we are just testing it.
All right. All right.
So you can see we have 77% too. Okay, not bad. So 77% is not actually bad, but yeah, it's not commendable enough. But yeah, it's not bad. So now let's try to let's see if our model is working. So you want to write something like this, input, and let me just write something like data, data input equals to. Okay. So the first thing is I want to rearrange some number. I know you may not understand, but just look through what I'm saying. So I want to rearrange some number. So let's do rearrange into into numpy array. So you have to do let's say data as number array as numpy array. So remember this. I want to there is a numpy array. Remember we've loaded our numpy, right? So you just want to do something like because I want to convert this one to numpy array. So you want to do something like np dots as array. Do you get? So what do you want to convert to numpy array? So I want to convert this particular data input. What will be in our data input? You will find out soon. So I want to convert this one into array, but this array now it will just be in row. I want to convert it into something like column. So you have to rearrange. You have to rearrange it. So this so instead of rearrange here, let me say conversion. Let's say conversion. So the next one will be rearranging. So we just want to do um something like this. Control C, Control V, dot reshape. So you want to do 1 comma minus 1. So we've we've arranged it, we've reshape it. So the next thing is we want to do okay. Let me just add something. Let me write so let me just say prediction now. So you can just say um model. Remember, my model is logistic regression. Model dot predict. What are you trying to predict? I'm trying to predict this thing. Okay. So now, what I'm trying to do is that this one. Remember, what I downloaded last one was with diabetes. So let's open it. So instead of opening it with my normal Excel, I want to open it with my notepad this time. So now let's see, we have the first one there. And see we have the first one, 648, all the values there. So we can see this one. What does this one stand for? Who can I make here? Like so I will know everyone is with me. What's this last one? What is it standing for?
It means the person has diabetes.
It means the person has diabetes. So I want to copy all this one. The first thing now. So now let's look at this. So can you see I not copy the results. So can you see these are the first like I want to know if this machine learning model will predict that okay, this particular person has diabetes or not. So let's just sorry. So so we want to print prediction. So let's see. So it's giving us that the person has diabetes. Okay, we want to know if our data is false. Remember, it's just saying 7% accurate. So I mean, put another data there now, and it will still return one, even though it is zero, which means okay, not every time it will be accurate because it's just saying 7. There are various ways on how to treat this. We can improve our data set, right? But let's try to do something. Where's the next part? So let's see for zero, the next one. So let's see if it will actually return zero. Interesting. So let's see if it will return zero. Okay, still returning one. Okay. Okay, let's try another one. Let's look at this. Okay, it's faulty. I see it's returning one. Okay, but let's try to make it one thing. So let's say quick prediction, and let's say is prediction. How did this thing know what I want to do? Anyway, so the person is diabetic. Okay. Um, this is quite wrong though. Okay, let's try to let's check on another one. So let's check on this one. This information that I'm picking, the person is actually diabetic. Okay, let's check on this. The person is diabetic. Okay, let's check on the one that is not diabetic, the one that follows it immediately. Okay. Okay, it's giving me an error. What's the error about? Okay, there should be 27. Person is diabetic. Okay, this thing is actually faulty. I guess you understand what I'm trying to do. Do you understand that, Babas?
Yes, I do,
At least, do
brother.
you understand the softwares?
Yes, I
Okay.
understand what machines.
Yeah, this is what we are trying to do. But now we can see the person is diabetic and the model is not accurate. And this is basically what we want to do. So how do we now scale? How do we correct this mistake? You want to ask a question?
I want to
I
ask
can
like
I hear
because
you.
it's not up to like the required, maybe not because it's not up to 85% or 80%. That's why we're getting these errors.
Yeah, exactly. It might be the reason. But we can be too forward. Now let's try to import more models here. So let's try. Maybe it might be because of the model. Maybe the model is not just accurate. So we have logistic regression only here. Now let's try to import another one. We have from sklearn. Can you see this is actually another one but in this place I want to do dot svm import as you see. So we want to do from sklearn um dot svm. Let's do okay, let me just do this one. Dot labels. Okay. Let's run this too. Let's see if this will be any better. So instead of our model to be logistic regression, we can just change this to SBC. Remember, SVC means support vector classifier. So I've run this one now. So let's try to fix it. So you can see my SVC is already running. So now let's check. This one is 77 at this point now. So what you can you see SVC improved the accuracy to 83%. Do you get that, Mr. Abbas?
Yes, I do.
Rafiat, are you getting what we are doing?
Yes, yes.
Okay. So we have 83% now. That means the more you know about model, the more you get more accurate results. You get that. So now let's check on our text score. So we can see on our training score it is getting 83. On our 75, there's actually a way to improve this one. You can just write something like I think K9 equals to linear array. I'm not sure but let's do. Okay. So now let's rerun this one. So let's rerun this one. So it's giving 78. What was it before? 80 something, right?
This is 3.
Okay. Okay, now it's giving 78. So my on text score is giving 76. It's better on text, but it's not better on this one. So don't worry, don't let me even jump. Let's just do the normal thing. There are different ways on how to solve this problem, but let's take it a step after the other so we won't spoil everything. Now let's just do our normal thing that we know. So sorry. So we have our experience again. So instead of last 25 again. So now let's try to look at this. Okay, we can still see the person is diabetic. Now let's copy another one. And this oh, okay, the person is diabetic again. What could I put in reason? Um, I'm trying to find a possible solution to this problem. What have we done? What have we done wrong? Okay, this is the model. Let's see. Let me see. Okay, let me check my accuracy score. I'm coming. I just want to check some things. Hmm, I'm coming. I'm still fine. I'm still working. Okay. Mhm. Okay, so I'm trying to debug it. I'm trying to see if I made a mistake. So we have this is how the person is diabetic and the person is not diabetic. Okay, let's see. No, standarditis possibly be diffuse. These are problems. Muscular gates. Okay, let me do something. Just Because no one that's a shape. One machine. That's not diabetic. Okay. I actually don't see an error in everything I've written, and I checked the model. Everything is working so well. So I don't know where the problem is coming from. Um, you know what? I think we postpone this to the next class, but then this is how to do it. I think I actually have the right thing. So it might probably be the model, but I guess not. The model is actually working good with 83.5%. So we actually get the main results. So next week we also do like short projects. Can you see this very short? But I don't know why they are returning just to one. So to next week, Saturday, we'll continue from where we stopped here. So it will be continuation of this one. I will try to look at what is going on. I want to know if it is my Google Colab, if it is this model, if it is my syntax. I want to know where the error is coming from. And if I'm trying to debug that now, I want to check if it is because I will be comparing different results. So everyone will just be lost and be like, what am I doing? So I guess in the next class, don't worry, we are still ahead of the class. I'm telling you. So let me show you the the stuff here. I think I know it. Okay. So you should not be scared. We are ahead of the class already. Yeah, I think I'm ahead already. So for data science. So we started the class like today is what, November 9. So these are our 6 week. So can you see, you're actually supposed to just do introduction to visualization. And you're already here. You're already doing something in the 8th week. You're already doing PLM, linguistic regression, and algebra. So you're already doing scaling and normalizing of data, introduction to machine learning model. That means you're already here. So don't worry. When we even if we move too slow, that means we are still ahead of the class. So I guess so. The assignment will be everything that I've done here. Everyone should return it. I'm thinking maybe if you do it in your own site, maybe your own Google Colab or Anaconda is working well, you may actually have the real answer. You get it may actually be correct instead of getting one. It may have 0 1 0 1, but then it will be something like this. So yes, that's where we stop the class for today. So I want to engage you, Andusala. Do you understand everything we've done in this class? Okay.
Yes, I did.
Abbas, yes, yes.
I would want to watch some videos like the past classes to be familiar with the code instead of having to check every time. But I understand the
Sorry, what do you
whole
say?
concept. I said I want
I
to be
can't hear
more
you honestly.
familiar with the. I said I want to be more familiar with the. I want to
Okay.
be more familiar with the codes, so I have to like watch the videos again. But I understand the concept already.
Oh, okay. So that's basically what we are trying to do. I think that's why I'm not trying to watch it. When we watch it, there are a lot of from learn from these videos. There are a lot of new things there, which I think it will take a little time to understand. So yeah, just go through this again, and yeah, we'll meet again next Saturday. So next Saturday, I will have figure out where the problem is coming from, and I will let everyone know about it. Okay, is that fine, guys?
Yeah, that's
Okay,
fine.
have a great day, everyone.
All right, thank
Bye.
you.